Hi, that's one question in homework 7 that a student asked me for help, and I think it is a good one to make a video so I can explain to all of you guys in the whole class. This question is actually really good because we can review the factoring techniques that we learned in the last chapter, and also how to subtract the two rational expressions. Now, in order for you to subtract any two rational expression or adding two rational expression, we have to find the LCD because we want to make the bottom part of fractions to look the same so that you can add or subtract any two or three rational expressions. Now let's take a look at this example or this problem. This problem is taken from homework 7, I think number 17. Okay, so we are trying to subtract these two rational expressions, and the bottom part of the first one is 3q squared plus 10q minus 8, and the second fraction has 5q squared plus 14q minus 24. And we can see that they are not the same things on both fractions, so we cannot just subtract these two fractions or rational expression right away. We have to find the LCD and make them to have the same bottom fractions before we can add and subtract the top together. Now, in order for us to find the LCD or the least common denominator, we have to find, or we need to find the common factor on both of the bottom parts here. And the only way we can do that is by factoring. We have to completely factor the bottom fraction on the left side and the same thing to the right side, and see what should be the LCD for both of them. So let's just try to factor the top, the bottom of the first one and the right one, and see what we get. Now the first one, we have 3q squared plus 10q minus 8. This expression here is a trinomial. That means it has three terms, and we can use the trinomial factoring techniques from the last chapter, and there are two cases. The first one is when the leading coefficient of the square term is 1 or it is not 1. In this case, we have 3, which is not equal to 1, so it is a little bit difficult, or it takes us a little more time to factor this one instead of just trying to find two numbers to multiply to get minus 8 and add them to get 10, if the case for 1 here. In this case, this is not 1, so we have to use something called the AC methods. So the AC methods will help us to solve this problem. So we have to use something called the AC methods, and I believe this one you guys already saw this from the last chapter. Now AC methods mean that we have to find the product A and C in this trinomial. Remember, we have something like ax squared plus bx plus c, and a is the coefficient of the square term and c is a constant. In this case, a is 3 and c is minus 8, so the product AC, or 3 times minus 8, is equal to minus 24, and your b is 10 in this case. Now we need to find two numbers. When you multiply together, we should have minus 24, and when we add them together, we should have plus 10. So if you do some trial and error, you should end up with 12 and minus 2, because 12 times minus 2 is minus 24. 12 add to minus 2, that is plus 10, or b. Now after you find the two numbers here, we have to rewrite the middle term 10q into the sum of 12 and minus 2 cube. So we can just rewrite 10q as 12q minus 2q. 12q minus 2q from these two numbers, and they subtract one another, they get 10q back, and we're not changing anything. And we carry out a minus a here. Now, after we rewrite the middle term into these two terms here, we can then factor this whole expression by using the grouping techniques. So I first group the first two terms together and the last two terms together. Now from the first two terms here, we can see that they have a common factor of 3 for the number and also q for the variable q. So I can pull out 3q from the first two terms. So if I pull out 3q, I only have q left here for the first term, because 3q times q is 3q squared. Now 12q divided by 3q, that's give me 4, because when I multiply these two back, I get 12q's. For the last two terms, I only see that minus 2 is the common factor, so I can pull out minus 2. Now minus 2, when I take that to the front, I have only q left for the first term, because minus 2 times q is minus 2q back here. Minus 8 divided by minus 2, that gives me plus 4. So when I multiply minus 2 to 4, I end up with minus 8 again. And then now you can see that we also have q plus 4 as a common factor from these two terms here. So I can again one more time pull the q plus 4 to the front, and when I do that, I get 3q for the first term, because when I take away q plus 4, I have 3q left. When I take q plus 4 away to the front, I have minus 2 remaining for the second term. Okay, so this should be the complex factor of the bottom parts of the first one. Now we do the same thing to the next one. 5q squared plus 14q and minus 24. Now again, in this case, this is not a 1, so I have to use the AC method. So A in this case is 5, and C in this case is minus 24. Now I need to find the product AC of 5 times minus 24, which give me minus 120. And my B is also 14 here. So now we need to find two numbers. When I multiply them together, I end up with minus 120. When I add them together, I get 14. So those two numbers could be 20 and minus 6 after some trials and errors. So 20 times minus 6 give me minus 120, and 20 add to minus 6 give me plus 14. After I have 20 and minus 6, I get the middle term 14q here, and then rewrite that as a sum of 20q and minus 6q. So I can now rewrite 5q squared, just carry it down, 14q now becomes 20q minus 6q, because 20q minus 6q give me back 14q and carry out a minus 24. And after we rewrite the middle term here, we can then factor this one by using the grouping. I can then group the first two terms and also the last two terms together. The first two terms, I can see that 5 is a common factor between 5 and 20, and also q is a common factor between q squared and q, so I can take away 5q. So take 5q, I have only 1q left for the first term, and 20q divided by 5q, I have 4 for the last term here. Minus 6q and minus 24, we can see that minus 6 is a common factor. When I take out minus 6, I have q left for the first one. Minus 24 divided by minus 6, that gives me plus 4, because minus 6 times 4 is minus 24. We can also see from here, minus q plus 4 and q plus 4 here, they are also the common factor, so we can take that away. Q plus 4, I can pull that to the front. When I do that, the first term I only have 5q left, and then for the second term I have minus 6 as the remaining number here. So this one is the complex factor of the denominator of the second fraction here. Okay, so let's now rewrite the first fraction and the second fraction rational expression using these two factors. So let me just rewrite the subtraction 2q plus 1 over what I have here. Now I want to write that in this factor form. So q plus 4 and 3q minus 2. And then subtract the numerator for the second one is 5q plus 2 over this one we just factored it out, q plus 4, and then 5q minus 6. Now we are already in the factor form. We can then find the LCD, or the least common denominator, for the whole fraction of the left and the right side. So we can see both of them, the bottom part here and here, they have q plus 4 to be the same. So that's why we have to take that, because they are a common term. And then the next one we have 3q minus 2, but this side we don't have that. That's why we have to multiply by that as well, 3q minus 2. And then this side 5q minus 6 we only have here and not here, therefore we have to multiply that as well to get the least common denominator for both sides, I mean both fractions. So after we find the LCD on both sides, I mean both rational expression, we can then write them by just a single rational expression. So I know that the LCD is this whole thing here, q plus 4, 3q minus 2, and times 5q minus 6. Now let's look at the first rational expression. We can see that q plus 4, 3q minus 2 we already have here, but we don't have 5q minus 6, therefore you have to multiply that to the top. So the top already have this one, so we multiply 5q minus 6 because we multiply that to the bottom, so make sure you do the same thing to the top. Now subtract, carry the subtraction sign here. Now 5q plus 2, make sure put that inside the parentheses so you are not changing the sign of the term here. Now we have q plus 4, 5q minus 6. We are missing 3q minus 2, therefore you have to multiply by that. Okay, so now it's time to simplify the whole thing. We can do the FOIL here. 5 times 2 is 10q squared. 2q times minus 6 is minus 12q. 1 times 5q plus 5q. 1 times minus 6 is minus 6. Okay, and then okay, I don't think we have enough spaces here. Let me try. Okay, hopefully we have enough spaces for the last one. And keep the minus sign here. So 5q times 3, that is 15q squared. 5q times minus 2, that's minus 10q. And 2 times 3q, that plus 6q. And 2 times minus 2, that is minus 4. Okay, that's good. And then dividing by the bottom fraction or the LCD, keep that to be the same. So q plus 4, 3q minus 2, and 5q minus 6. Now it's time for us to simplify the numerator here by distributing the minus sign to each of the individual term here before we can do further simplification. So I rewrite 10q squared minus 12q plus 5q minus 6 minus of 15q squared minus and minus of 10q, that's become plus 10q. minus and plus 6q, that become minus 6q, and minus to minus become plus 4 here. And then again, you want to rewrite, carry out the whole bottom part or the LCD again, 3q minus 2 and 5q minus 6. Now it's time to simplify this whole rational expression. So we see that the q square, we can combine the like term, 10q square and minus 15q square, that is minus 5q square. So we can take that away. Now the next term is the q, minus 12q plus 5q plus 10q and minus 6q together should be minus 3q when we combine the like term. And then so we cancel that, take this away, minus 6 plus 4, that is minus 2, and all together over the same least common denominator here. So q plus 4, 3q minus 2 times 5q minus 6, and this should be the final answer for this problem. And let me go back and check to make sure that we have something correct here. So let me check the answer. Yes, it's minus 5q squared minus 3q minus 2 over 3q minus 2, which is here, times q plus 4, which is here, times 5q minus 6, and this should be the answer for this problem. So again, anytime that we are subtracting or adding any two rational expression, we need to have the same denominator, or you have to make the LCD for both of the rational expressions. And by finding the LCD, we are trying to find the common factor of both of the rational expression. And by finding the rational expression, the common factor, we have to factor completely each of the bottom part for the rational expression here. And if the leading coefficient is not a 1 for the square term, you have to use the AC method, as in this case. If that is the 1 here, then it's easy. We just have to find two numbers. When we multiply, we get minus 8. When we add them, we get plus 10. And that should be the factor for the whole expression. Alright, thanks for watching.